Okay, this is your notes for section 6.3, separation of variables. And example 1 says find the general solution of x squared plus 4 dy dx equals xy. So remember what we talked about when it says find the general solution. That means we're usually going to have y equal something. And the first thing we have to do is separate our variables and then integrate. So always remember, separate and integrate. So when we separate our variables, that means our x's, anything with the x has to be on one side, anything else that has a y will be on the other side. One other thing you want to keep in mind is anytime you have a dy and a dx, you always want that dy or dx to be on top. You never want it on bottom like this. So I automatically know that I want this dx over on the other side, so it will be on top, okay? So let's we're going to get our y's on the left-hand side because my dy is on top. We're going to get our x's on the right-hand side. So the first thing I'm going to do is I'm going to multiply this whole thing by dx. So I have x squared plus 4, because these dx cancels, dy equals xy dx. So the good thing is my dy and my dx are now on top. They're not in the bottom of a fraction anymore. So I know that I need my y's on this left-hand side. So I'm going to get rid of this x squared plus 4. So now over here, these cancel, and I just have dy equals xy dx over x squared plus 4. Okay, so now I need to get this y over on the other side, and I'd have to divide by y. So do you see that I would have dy over y equals x over x squared plus 4 dx. Okay, so now I have separated my variables. Okay, y is on the left, x is on the right. So once we separate, now we're going to integrate. So we always show that we're integrating both sides. So I'm going to have to write a little smaller. We're going to integrate 1 over y, which here's my 1 over y, dy equals x. I'm integrating x over x squared plus 4 dx. Okay, so when I integrate this side, the integral of 1 over y is natural log of absolute value of y. Okay, when I integrate this, I'm going to have to use U-substitution. If my u is x squared plus 4, du is 2x. Okay, so here's my u. I have part of my du. I'm missing a 2, but I can put the 2 there as long as I put the 1/2 out in front. Okay, so I'm going to rewrite this part over here. I have 1/2, 1 over u du. Do you see that? Here's my du. Here's my u, so I have 1 over u. So when I integrate this, I have 1/2, the natural log of u, but u is x squared plus 4. And remember, we just need our plus c on one side. Okay, so now to solve, because remember, our answer is going to be y equals something. Here's my y, but it's with this natural log. To solve for y, when it's inside a natural log like that, we're going to e both sides. So I have e to the natural log of y equals e. Do you see that I can use properties of logarithms here? This 1/2 used to be an exponent. So this is actually x squared plus 4 to the 1/2 power, or the square root. So I'm going to write it like that. Natural log of the square root of x squared plus 4 plus c. So now that we e both sides, e to the natural log of something is that something. So I have y equals And since it's absolute value y, it can equal plus or minus e to the natural log of something. So I have, this is going to be um, e, let's see here how I want to write this. I'm going to rewrite this first. This is going to be e to the natural log of the square root of x squared plus 4. And whenever it's addition, do you remember how we can rewrite that using properties of logarithms as multiplication? Okay. So now I have y equals, all right, e to the c. E to the c is just a number, right? C is just a constant, so that's a number. And I'm going to call that c. So c can be positive or negative. So there's my positive or negative constant. E to the x squared plus 4. And that is your answer. Okay, let's look at example 2. Given the initial condition, y of 0 equals 1, find the particular solution of the equation. So first of all, we have to separate and then integrate. Okay, the good thing is dx and dy is not in the bottom. Okay, my hint here is I'm probably, anytime I have something that's being added, I'm probably going to want to put that over on the other side. So my first step I would do is x, y, dx equals, and I'm going to subtract this whole thing, minus e to the negative x squared, y squared minus 1 dy. Okay, so we know this side can only have x's, this side can only have y's because I'm matching it up with the dy and the dx. All right, so the first thing I'm going to do is I'm going to get rid of this y. And I'm also on the same step, I'm going to get rid of this because it has an x with it. So I'm going to divide by y, and I'm going to divide by negative e to the negative x squared. So when I do that, I have x over, and I'm going to divide by this, so I have negative e to the negative x squared dx, y squared minus 1 over y. So I just moved everything so that it's where it's supposed to be. Okay, the other thing, just to make it easier before I show that I'm integrating, I'm going to write these as simplified as possible. So see how this is a negative exponent? I'm going to bring this up to the top to make it positive. So really this is x and negative e, so I'm going to put that negative in front of here. E, now it's to the positive x squared because I moved it up on top. And over here, do you see that I can simplify this? I can put y squared over y, which is y, negative 1 over y, which is just 1 over y, dy. And now I'm going to show that I'm going to integrate both sides. So I'm going to integrate negative x e to the x squared dx. And I'm going to integrate y minus 1 over y dy. Okay, so when I integrate this, if u is x squared, du is 2x. I have an x and I have a negative. I can bring that negative out, but I'm missing the 2. So I can put the 2, but I need the 1/2 out in front. So really I have this. I'm going to bring this negative out in front. So I have negative 1/2. Here's my u. This is my du. So now I just have e to the u du. And over here, I'm just going to leave it because I don't need to use U-Substitution. All right, so let's actually integrate. Negative 1/2. When I integrate e to the u, it is e to the u, so e to the x squared equals, and I'm going to integrate this side, y squared over 2 minus the integration of 1 over y is natural log of y plus c. Okay, now in this problem, the directions said, given the initial condition y of 0 equals 1, find the particular solution of the equation. So that means I'm going to plug 0 in for x and 1 in for my y. Okay, so I can go ahead and do that at this point. Okay, I'm going to go ahead and write down that point again. It was 0, 1. All right, so now let me change my pen. I'm plugging in my point. So I have negative 1 half e to the x squared, but my x is 0. My y is 1 minus natural log of 1 plus c. And we're solving for c. So e to the 0 is 1, so I have negative 1 half equals 1 half minus 0, but natural log of 0 is 1, plus c. So we know c is equal to negative 1. So now I'm going to take negative 1 and plug it back in to this equation. Okay, so I have, change my pen one more time so we can kind of see what we're doing. Negative 1 half e to the x squared equals y squared over 2 minus natural log of absolute value of y minus 1. But remember what we want. We want to solve for y. So let's multiply everything by 2 to get rid of this. So if I multiply every single thing by 2, 2 times this, that's just going to give me negative e to the x squared equals y squared minus 2 natural log of y minus 2. And so on this one, since I have a y squared natural log of y, we can't really solve for y. So let's get everything over. You can leave it like this and it wouldn't be wrong. Let's get everything over to the left-hand side except my constant. So I could say I'm going to move everything. Here I have my y squared minus 2 natural log of y. I'm going to bring this 2 over here and this e to the x squared over here. And that is my answer. Okay, last one. Find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. Okay, so first of all, our equation, they said the slope is this. Well, slope means y prime is this. So remember, y prime is just another way to write dy dx. So here's my y prime. That means I need my y's on the left, my x's over here. So I need to divide by y. I need to put this over here. So now I really have y prime over y equals 1 over x squared, or I'm going to write it as x to the negative 2. And even though it's not showing a dx, I'm going to go ahead and put it. Now I separate my variables. Now I'm going to integrate. That's why I wrote this as x to the negative 2. Okay, and I have natural log of y equals x to the negative 1 over negative 1 plus c. Okay, so now here's the equation. I need to solve for c, and I solve for c by plugging this point in. So I have natural log of y, which is 3, or before I do that, I'm going to go ahead and solve for y before I start plugging those in. Okay, so if I want to solve for y, I need to e both sides. Before that, I have natural log of y I'm going to rewrite this as simple as possible. So now e both sides. And now I have natural log of e to the natural log of y is y equals e to the negative 1 over x plus c. So y equals, this means e to the negative 1 over x times e to the c, which means y equals, this is just a constant. And now I'm going to plug in my point that they gave me, 1, 3. Okay, so I'm going to plug in that point. Y is 3. C e to the negative 1 over 1. So c is 3 over e. And then I'm going to take this, plug it into that equation. So my answer would be y equals 3 over e, because that's what c is, times e to the negative 1 over x. And that is your answer. Okay, your assignment for 6-3 is on your assignment sheet that you have. I'm going to go back and look at something real quick on example 1. E to the natural log. I'm just looking really quick. I may need to check this answer. Okay, this is actually example 1 in your book. So check and make sure, I don't have it in front of me, check and make sure that that's what they have as their answer. I'm wondering if I messed up someplace. I'm not sure. But we will talk about it Tuesday when I get back. Have a good day.